very good morning, everyone. Today, Dr. Mahima Punya Singh is going to deliver a lecture on gradient divergence and curl from chapter Vector Calculus. Firstly, we'll be starting with the introduction of vector calculus. Here, I'll be teaching you about the vector differentiation. Secondly, the gradient of vector. Thirdly, the divergence. And fourthly, the curl. In this video, we'll be discussing the only two topics. Those are vector differentiation and the gradient of vector. Now, let us start with the vector differentiation. Here, we are considering a surface thus, and the origin of this surface be at O. Now, our particle is lying at some point P on the surface at some time T. Then the function at this point will be given by ft, and the position vector of this OP is given by r. Now, after some time delta t, let the particle have moved to point Q. At this point, the function will become ft plus del t, and the position vector of this OQ will be r plus del r. Here, PQ will be given by subtracting the position vector, or you can say it is denoted by del r, and it can be obtained by subtracting the function at Q from function at P. Now let us assume at some time T, your P at some time del T, let us suppose del T tends to 0. Then this your Q point will lie on P. This can be calculated by taking the limit where delta t tends to 0. Your vector will be del r over del t, and or you can write it as f t plus del t minus ft over del t. Fine. If this value exists, then you can write it as dr over dt. And this is your vector differentiation. Now, what is scalar point function? For that, let us explain with the help of a function. Let us consider a function phi x, y, z, where this coordinate x, y, and z are not denoting any vector quantity, means it is not depending on any direction. Then in that case, this function is your scalar point function, where if it donates some vector quantity or a direction, then that point is known as vector point function. Let us start our topic, gradient of vector. For that, again, let us consider two surfaces. Let the first surface be phi is equal to c, and the second surface be phi plus d phi equal to c. For this, let us suppose these two surfaces must follow two conditions. First, they must never intersect, and secondly, they must be on same level, such that they have the same origin, that is O. Let us suppose our point is lying at particle is lying at surface 1 at point A. Fine. And at surface B, it is lying at point B. The position vector OA is given by R. The position vector OB is given by R plus del R. And this AB will be fine. The gradient phi will be calculated by taking the partial derivative of phi with respect to x plus I cap plus partial derivative of phi with respect to y j cap, partial derivative of phi with respect to z k cap, and your R position vector is given by x I cap, y j cap, z k cap. So del R will be obtained as dx I cap plus dy j cap and plus dz k cap. The dot product of these two functions will be given by partial derivative with respect to x into dx, partial derivative with respect to y into dy, del y. Here it is del x, partial, sorry. Let us erase it first so that it should be clear to you all. Here we again take our pen. partial derivative with respect to phi into dy, partial derivative of phi with respect to x. Fine. Let us suppose they must lie on the same surface, or B is lying on A is lying on. Then the value of theta will be 90 degree between them. And we know that the dot product of two vectors A dot B will be obtained by taking the modulus of A and B into cos theta. And here cos 90 is 0. Therefore, the dot product will be 0 for this case. Similarly, it goes for the gradient of vector. Or you can say that you will obtain this for the case of normal values. Now we'll be explaining it with the help of your example. In first example, we'll be solving this example and we'll be calculating the value of gradient for the function phi. Here we can calculate the gradient of phi by curl x, curl y j cap, curl z, or partial derivative with z. Phi function is here. This. Now, partial derivative with respect to x will be 6y minus 0 I cap. Partial derivative with respect to y will be 6x. Again, it will be y is 1. So, derivative of y will be 1. Here again, we'll be taking eraser. Oh. Eraser. It will be 3x square and 3y square z square j cap. Now, the partial derivative with respect to z will be 2y cube z. Fine. Now, substituting the value of this, it will be 6 minus 2I cap plus 3 into 1 square, 3 into minus 2 square into minus 1 square j cap minus 2 into minus 2 cube into minus 1 k cap. Again, it will be minus 12I cap plus minus 9 j cap plus minus 16 k cap. This will be the gradient value for the phi value surface. Now the example 2, you have to calculate the unit vector normal. Again, firstly, you'll be calculating the gradient of the surface. It will be partial derivative with respect to x I cap, partial derivative with respect to y j cap, partial derivative with respect to z k cap, and the surface will be x cube plus y cube plus 3xyz equal to 3. Again, partial derivative with respect to x, if you are taking it as 3x square plus 3yz, fine, I cap. Then with respect to y, it will be 3y square plus 3xz j cap plus with respect to z, it will be 3xy. Now substituting the value of xyz, 3 into 1 square plus 3 into 2 into minus 1 I cap plus 3 into 2 square plus 3 into 1 into minus 1 j cap plus 3 into 1 into 2 k cap. Fine. It will be 3, 6 minus 3 I cap. It will be 12 minus 3, 9 j cap. It will be 6 k cap. Now we will be taking the unit vector for this vector. Firstly, we will be calculating the modulus of the vector. It will be minus 3 square plus 9 square plus 6 square. And you will obtain it, it will be 340. Then the unit vector of this function will be given by minus 3 I cap 9 j cap plus 6 k cap over 3 raised to power 40. Fine. Here we end our topic of gradient of vector. For more references, you may consult the following books. And thank you. Have a nice day.